Hello everyone, myself Dr. Sonam Gupta, working as a professor in the Department of Computer Science and Engineering. So today I am going to discuss a complex topic in software project planning and management, which is selection of the process models. Now, the selection of the process model plays an important role for completing a project because the choice of right process is very much required to deliver the project on time and within the budget. So there are various approaches on which this selection depends. First one, if it is in-house development, then most of the issues they are resolved by IS planning and the standards. Secondly, if there are software houses, they are more applicable as different customers have different requirements. Now the selection process is governed by first one, uncertainties of the project. If any uncertainty arise in the project, then it is governed by the approaches. Properties of applications which are required to be built. So that is again a criteria for selecting that particular approach. General approaches which is there is looking at the risk and uncertainties, like what can be the things. Are the requirements well understood? Now, this is a two-way process. Are the requirements well understood by the customer as well as by the developer who is developing the project? Second one, are technologies to be used well understood? The technologies which are going to be used in the project, they are well understood or not? Now, let's see the type of the application which is being built. Like for example, whether it is an information system or an embedded system. This we had discussed earlier lectures as well. What is information system and embedded system? So we need to identify that whether the application which is to be built is an information system or an embedded system. Second is criticality. Now, there are differences between target and the development environments. Is there any difference between both of them or they are the same? So that needs to be identified. Third one, client is having its own requirements, right? It need to use a particular method for it, or secondly, it depends on the choice of the process models. Now, first model is the waterfall. It is also known as one shot or once through. Second one is incremental delivery. Third one is evolutionary development. And along with this, we are having agile methods also, which is known as extreme programming. Now, use of the agile methods and the extreme programming as well. So, these are the few process models that can be done. So, first one is the waterfall model. Now, let's see over this waterfall model. It is having various stages, as you can see in the figure also. In these stages, we are having feasibility study, user requirement, analysis, system designing, program designing, coding, testing, and finally the operation. So this is a waterfall model. As we can see over here, the design is in a waterfall structure. Like if we are going in a waterfall from feasibility to user requirements, and suddenly there are changes come in the user requirements, then we do not have any option to go back. So this is the main thing of the waterfall model. So if we are implementing waterfall model for any process, then what is required? The main thing which is required is if we have completed any one step, then we must be very sure that we do not have to traverse back at the previous step. So for this, waterfall model is required and that can be implemented as well. Now, waterfall model, it is the classical model and it imposes structure on the project. At every stage needs to be checked and signed off. Why it is said so? Because we do not have any option to go back to the previous stage. So, if we are at any stage, then that stage needs to be completed successfully. But there is, as we had seen, there is limited scope for iteration as well. Why there is limited scope for iteration? Because we can only move forward. We cannot move back in backward position. Second one, we can see over here V process model. So this is another enhanced version of waterfall model, or we can say it is another way of looking at the waterfall model. It is known as a V process model since if we can see this, it is in the shape of the V. So it is a V process model basically. So the steps are still the same, like feasibility study, user requirements, system design, programming design, code, then program testing, system testing, user acceptance and review. Now, what is the V-shaped model advantage? Advantage is that if we are suppose at the program testing part, here also if we are moving in forward direction, we cannot move at the backward direction. So the arrows has been shown as it is, like feasibility to user requirement, to system design, to program design, then to code. Now if we are at the program testing, okay, and we need some corrections to be done in it, so how that can be done? To do those corrections, we can directly go to this program design, but we cannot move from program testing to the system design. So the ladder is fixed, the level is particularly fixed, which step can be used to move at what particular step. Similarly, after program testing will come the system testing. Okay, now from this system testing, if any corrections occur, then it will go to this system design. Similarly, for user acceptance after system testing, it will go for the user acceptance testing. For the user acceptance, if there are certain corrections, then that need to be done in the user requirements. So, corrections will be done at the user requirement part. Similarly, from user acceptance, it will go to the review. From the review, the corrections will be done and it will go to this feasibility study part. So, here we are just having an open hand to go to a particular stage. But again, that stage is also fixed. We cannot move here and there just as it is. For that, we need particular level, and to that level only we can go to that previous stage. Next is evolutionary delivery, or we can say prototyping as well. So, an iterative process of creating quickly and inexpensively live and working models to test out the requirements and assumptions. So, for this, evolutionary delivery is required. So, we are having Sprague and Menkler mean types for this. These are, we can also say, the throwaway prototypes, because we are just building a particular prototype to show the customer its requirements, because many are the chances that the customer is not aware of its requirements. So, for that, evolutionary prototype will come like a helping hand. So, we are having evolutionary prototypes for it. So, what is being prototyped, we must know. If we know what is to be prototyped, then the prototype will be made, and then the customer can also be made aware that, okay, this is a prototype that was to be built, and then the customer can make the changes in its requirements. Like human computer interface is there, some interventions from the human is required to the computer interface that is being developed. Functionality, what are the functionalities that that particular software is going to support, like login, mails, photographs, or we can say the messages, anything, calendars, doc files, PowerPoints, drives. So anything, what are the functionalities over here? Now, why we need this particular prototyping? Because it is learning by doing. We had make a prototype. The prototype is shown to the customer. Now, when the prototype was shown to the customer, then the customer will have more ideas about its requirements. So, and thereby also the developer can also learn how to do the things in a proper manner. Second is improved communication, because there is a communication barrier between the customer and the project team. So, that barrier can also be removed through it. Improved user involvement, because now we are going to show that particular type to the user, or we can say to the customer. Then now when he will be looking over that particular prototype, he will be suggesting some changes or giving new requirements. So, thereby the involvement of the user will be very high. Feedback loop will be established, because once suppose a prototype is developed, customer will be shown this particular prototype. If the customer is not liking this prototype, then through the feedback, the prototype can be changed. So, this is the feedback loop which is established in this prototype model. Reduces the need for the documentation, because hand to hand all the things are being shown to the customer and there only the changes are done. It reduces the maintenance cost, that is the changes after the application, it will go live. Prototype, it can be used for producing expected results. So, what are the expected results from the customer side and what can be done from the programmer side also. So, prototype can be easily used for it. Now, there are some dangers of the prototype also. Users may misunderstand the role of the prototype because they may think that this will be the complete project and the development team is not able to develop this particular project successfully. So, this can be a one danger to it. Lack of project control and standards possible because more and more involvement of the customer is there in the project. So, there might be a chances that we are not following all the standards which must be there. Additional expense of building the prototype because it is an extra step for building a particular project. So, there is an additional expense of building that particular prototype. Focus on user friendly interface. It could be an expense on the machine efficiency because it may be the thing that suppose the user he is liking much more photographs, or we can say the images which is of high resolution on its website. Now, to please the customer, we are just pasting all those images onto that web page, but thereby reducing the efficiency of the machine also. So, that can be one danger. Now, what are the other ways of categorizing the prototyping? What is being learned? What is to be learned from that particular prototype? We can categorize it successfully. Organizational prototypes are there. Hardware or software prototype, that is experiments, can be there. Application prototypes which are exploratory in nature, that can be done. Now, to what extent the prototypes can be categorized? If we can have the mockups, that is not the exact project that is being declared, but like a mockup, we can have that particular prototype. Simulated interaction, that means interaction in a simulation environment, behaving like how the software is going to behave in the real world. We are seeing its interaction in a simulated environment. So, that can be another aspect for it. Partial working models like vertical or horizontal. So, this is another aspect for it. Next is the incremental delivery. Like we can see over here, for the incremental delivery, we are having this ladder, this delivery system is there. So, we are having increment 1, 2 and 3 over here. For the first incremental delivery, stages will be design, build, install and evaluate. This one module is developed and this first incremental delivery goes to increment number 1. Secondly, after that, this second incremental delivery, which composed of the same components as was in the first delivery, that is design, build, install and evaluate, and then it will go to this increment number 2. Now, similarly, the third module is also developed by the help of this third incremental delivery, having the same module, same components, same steps, that is design, build, install and evaluate, and then going to increment number 3. Now, this will be the complete process. If we see, this is a delivery plan. Identify the system objectives, what are there, create open technology plan, then plan the increments accordingly. So, this will be the first increment. For the second one, for each increment, what we are going to do, we are designing the increment, like first increment is design, second is design, third is design. Then we are building the increment, the design for the increment, and then on the basis of that design, the building of the increment is done. From the build, implementation will be done and then we will be evaluating those results, that whether it is correct or not. One increment is developed, then after evaluation, the feedback will be done over designing the increment. And this feedback loop will continue till we have succeeded. Second increment comes, then also we need to follow this particular step. So, this is how this incremental process goes on. Now, what are the various benefits of this incremental approach? So, feedback from the earlier stages is used in developing later stages. So, if we had done any, faced any issue in the previous stage, then that can easily be resolved in the later stages. Shorter development thresholds, user, it may get benefits earlier because module by module delivery is there. So, maybe the thing that user is able to solve its particular problem for one module. Maybe it's not able to access the complete module, but for some part of the module, they are able to complete their work. projects may be put aside temporarily, and it will reduce the gold plating as well. But there are some possible disadvantages also, because first one, loss of economy of scale. That can be one disadvantage. Software breakage, because module by module is delivery is there. Now suppose at any point of time the customer says, okay, now we do not want the project to be completed. So that is a software breakage which can come. The outline incremental plan is that it steps ideally 1 to 5% of the total project. Non-computer steps, it should also be included in it. It is ideal if a step it takes 1 month or less, then we can use this incremental plan. But if it is taking more than 3 months, then we are not required to take this incremental plan. Each step, it should be delivered with some benefit to the user. Some steps, they will be physically dependent on others. So, we have to manage that particular thing. Now, next question arises, which step will come first? So, we all know that some steps, they will be prerequisite because of the physical dependencies. It may be the thing that 1 or 2 modules, they are dependent on another module. So, we have to take care for that. And the others may be in the order, they may be dependent or they may not be dependent on it. So, that will depend module to module. Value to cost ratios, it can also be used. So, value to cost ratio. So, if it is V, that is value, it is a score from 1 to 10 which is representing value to the customer. And C, it is the cost which is from the score 0 to 10 which is representing values to the developers. So, this is a particular example. Steps are profit reports, online database, ad hoc inquiry, purchasing plans, and profit based pay for managers. So, value or cost ratio we are having, values and the cost ratios are calculated for that, and based on that the places are defined like first, second, third, fourth and fifth depending on the ratios. Now again, next thing is agile methods. So, agile methods, they are structured development methods and they have some perceived advantages, like they produces large amount of documentation which can be largely unread. And then we have to keep the documentation up to date as well. So, division into specialist group and need to follow the procedure stifles the communication. And users, they can be excluded from the decision processes. Another disadvantage is long lead times to deliver anything, etc., etc. So, now the answer for all these questions is the agile methods. Okay. So, agile methods, we can say that they are the dynamic system development method. They are based on UK based consortium, and this dynamic system development methods, we can see it as a replacement for the structured system development method. And this dynamic system development method, it is more a project management approach rather than just a development approach. And along with it, we can also use DFDs, LDGs, etc. in it. So, there are basically 9 core DSDM principles. What are these? First one is active user involvement. Next, team empowered to make the decisions. Third one, frequent delivery of the products. Fourth, fitness for the business purposes. Fifth, iterative and incremental delivery. Sixth, the changes which are done are reversible unlike structured one. Seventh, requirement baseline, they are at a high level. Now, eighth one, testing, it is integrated with the development. And ninth, we are having a collaborative and cooperative approach for it. So, this is a particular figure, feasibility study. Review the prototype, agree for the schedule, create the functional prototype, identify the functional prototype. This is the function mode iteration on it. Next is if we are designing or building the iteration, then designing the prototype, schedule, prototype, then review the design for the prototype. If we are implementing over it, we need to have the implementation part, review the businesses, train the users and user approval and the user guidelines. So this is a time boxing of DSDM. Time box, this is the fixed deadline by which something has to be delivered. And more or less it is from 2 to 6 weeks. And we are having Moscow priorities for it. What is Moscow priorities? It is must have, that is essential. Should have, that is very important, but system could operate without it. Could have, that is C, and want, but probably won't get for it. So another, it is the extreme programming case. So increments of 1 to 3 weeks can be done. Customer, they can suggest improvements at any point of time. They are argued that the distinction between the design and the building of the software, it is artificial in nature, and code is to be developed to meet the current requirements only. So frequent refactoring is required to keep the code structured. Now in extreme programming, the developer works in pair, and the test cases and the expected results, they are devised well before the designing phase. After testing of the increments, the test cases, they are added to that particular consolidated test cases. So this is a Grady-Booch concern. It's an object-oriented authority and for the different projects, and it says that the conceptual integrity, it sometimes suffer because this is little motivation to deal with scalability, extensibility, reusability or portability beyond any vague requirement it might imply. So this is how we can do the particular selection of the process models, various process models which are there, and thereby we can choose a right process. So this is the microprocesses. So microprocesses are there, we are having checkpoints. Similarly, second process will be there, second module will be there, again the checkpoint, then we will be going to this third process, and thereby the cycle will continue for it. So if uncertainty is high, so then we use evolutionary approach. If complexity is high but uncertainty is not, then we are going to use the incremental approach. If uncertainty and complexity both are low, then use one-shot approach. And if the schedule is tight, then use the evolutionary or incremental approach. So these are the few things through which we can easily choose the process model. So these are the various combinations that we have just discussed. Thank you.